Hello, I'm Simon Floyd, Director of Global Manufacturing Industries at Google Cloud. It's my pleasure to welcome you to the third episode of the Smart Factory Transformers. In this new video series from Google Cloud, we tell the exciting stories of how manufacturers are in the midst of a transformation journey, digitizing production processes and reinventing customer experience using data and AI. In this episode, we will talk about remote field equipment management and how Manufacturing Data Engine can be used for scenarios outside the factory to facilitate digital services for customers of manufacturers. What we can see immediately on this screen is a really nice visualization of where the equipment currently sits geographically, focused in this particular case in North America. We have 2,945 assets currently being monitored. Around about 286 of those are currently under warranty, and there are 244 alerts and other key KPIs that we need for the business, which you can see on screen. Now, importantly, when it comes to the opportunity for additional business, we can see just below that there are actually asset upgrade opportunities according to the warranty expiration date. And this is the combination of two different sorts of data. This is taking together the purchase order information, the sales information, and then combining it with the operational status of the equipment. So we can combine both of them to say now is a good opportunity to do an upgrade for the customer based on the utilization of the equipment itself, and also worked on the expiry date for their warranty. So we've got very good kind of sales lead information that's coming through in this particular dashboard that you see. And we also see a number of critical alerts coming through on this same dashboard that provides us with an opportunity to provide more service directly to the customer and provide our own organization with additional insights. So what we're going to do is take one of these assets right from the top here that is showing an abnormal engine speed, and we're going to dig into this one to find out what's going on and come up with the right type of solution for this customer. So first of all, let's open this one, and we'll just take this now full screen. Okay, so what we have on hand here is a backup power generator that you can see on the left-hand side. And on the right-hand side, we've got instantaneous information that's being provided to us. One, we can see the asset location, which we take actually from the purchase order, and we look at the delivery location, so where it's being actually delivered. The alternative to that is where we get signal information such as GPS. What we do here is just get the general location, which we need for when we would want to schedule service, or for when we would want to be in contact with perhaps a local dealer or value-added reseller. So just for fun, in our fictitious manufacturing company, we've had them sell a power generator actually back to Google Cloud. And so here is a visualization of one of our data centers, and we know that the equipment is operating somewhere on this location. And using Google Maps that you can see here, it does give us the opportunity not only to understand more about the overall environment, but then it does allow us to do some additional things such as calculate the distance to the local dealer that I spoke about, or perhaps work out how much time there will be to deliver from a warehouse directly to this site if we were doing spare parts or wishing to send someone on site for service. So having a little integration as simple as that can actually be very insightful for when we're working directly with a customer. Now, what else we see up on screen here is that there are some really nice KPIs, some good performance indicators that we can see that help us understand the overall status of this equipment with the customer. A couple of things are critical that we can see, or one that is critical and others which are approaching. The first one being that 40 days remaining until the battery is recommended to be replaced. We can see some things here which are very good. So our coolant level is still looking very good, but we've had a few failures to start, which on a backup generator is really not a situation that we want. Now, continuing along, we can also see an overall aggregate of the equipment health. There is a asset score, which we calculate on the fly, which would be at 100 when it's delivered to the customer. Currently, it is at 60, so therefore not exactly where we would want it to be by specification. And we can also see some of the indicators as to why. So the alternator health is in the yellow zone, so it's not looking particularly good, I would say. And the engine health overall has been severely impacted. Now our task is to try and work out why. So we've got somewhere to begin, but now we need to look for some more specificity. So continuing on, what do we see at a glance? Well, the first thing that we can see there, just looking at the overall properties of this generator, that according to the runtime that we can see there by cycles, so how many times we've had a start and a stop sequence, that at around about the 80 cycles, we had a fairly significant drop in voltage. And the role of this generator is voltage and current. And so this is what it needs to do. And it's simply not performing its task. We can also see that the load hasn't increased. And so there wasn't as if we suddenly overloaded the generator that's causing this particular situation. The root cause of this is yet to be known. We have to continue to drill down. So let's see if we notice anything else. One of them that we check always is vibration. And in any type of mechanical equipment, excessive amount of vibration can lead to breakdowns, mechanical breakdown. So we do see a fluctuation there at a glance in the equipment, which could be a leading indicator of other underlying problems in this particular generator. So let's dig into this generator. And we have the asset ID, we've got all the information, firmware number, and so on we have from the equipment itself. So we've got an idea of what this particular piece of equipment is. Now we're going to dig into some of the sensor information and see if this is going to help us understand what's currently going on. So we do see a couple of interesting things here. One is that there was a slight increase in pressure, but over specification, and the engine has tried to increase speed at the same time, which is perhaps not something that we were really looking for. So the machine is trying to compensate for a particular circumstance just to keep its performance where it needs to be. But despite its best efforts, we can see that the efficiency is actually all over the map. And so we're not getting anywhere close to where we would want to be. Obviously, we would want to be much higher level efficiency and much more consistent. Now, another interesting thing that we've noticed immediately is that fuel consumption has literally gone through the roof, which is something that we would not want to see ordinarily. And so there must be some leading indicators as to why. And continuing on, we can see even more dire circumstances that the voltage has also dropped fairly significantly. I would say that this generator is now approaching a critical situation. Now, to know more about exactly how critical it is, we perform a core calculation using machine learning and artificial intelligence to create a score for remaining useful life. Now, this is an approach that many types of manufacturers use around the world for different types of equipment to calculate a threshold of inefficiency. This is where the equipment is no longer efficient, but it may continue to run, but it's just running very poorly. I would say this equipment has crossed that threshold, and we can see there that actually the amount of cycles remaining, we would normally want to see many more, is actually getting very low. So we're going to go below 60 cycles remaining. We've already crossed that, and it looks like that the predicted going forward does not look good when we get beyond 40 cycles. So therefore, we know that this piece of equipment needs to be maintained almost immediately. Now, why? What is going on that would be causing this? Well, we see something quite interesting. First of all, that there is high coolant temperature. We see that there is intake manifold temperature that is high. It's generating a code on the diagnostic computer. We're getting an instant understanding of what the outcome of that code was. So it was a shutdown. In one case, it was a warning. All of this information is available to us instantaneously and at a glance. But because we're storing it in Manufacturing Data Engine, it does provide us with digital twin capabilities so that we can understand specifically what needs to be done for this customer and for this particular asset. And if we look over here on the right-hand side, there are some recommended actions which will take care of part of the condition. One is we should replace the air filter within the next 15 days. The battery we already worked out was critical at 40 days, and so it needs to be replaced. And we're saying we should schedule maintenance in order to take care of these bigger items which cannot be performed directly by the customer themselves. And so therefore we will put a schedule together. And that concludes my demonstration for today. And I certainly hope that you found good value in this particular approach to using an underlying data engine in order to manage assets at large, whether it be for understanding the maintenance exposure for the customer or whether it's understanding things such as sales opportunities. Many thanks for spending time with me, and I certainly hope that you found this episode interesting and informative. Have a great day wherever you are in the world, and many thanks again.